55, section 6.2. In this lecture video, let's take a look at perimeters and area of our polygons. Alright, so I mentioned something about quadrilateral last time. So here I have 4 of those specific quadrilateral: rectangles, squares, parallelogram, and trapezoid. I also have triangle here. So alright, here are the definitions of all 5 shapes, and I got perimeter formulas on one side and I got area formulas. So basically, in order to find perimeters of a polygon, we're simply gonna just add up all the sides. Alright, so let me kinda quickly talk about this real quick. Rectangle, characteristic of rectangle is a quadrilateral with 2 pairs of parallel sides. So the length and the length are parallel, the width and the width are parallel. And it consists of 4 right angles. 4 interior angles are 90 degrees each. We denote the longer side as length, okay, and the shorter side as width. So the opposite sides, okay, the length and the length are parallel and also congruent. So that means the length and length are the same, the width and the width are the same. Alright, to find the perimeter, we just say L plus L, which is 2L, plus W plus W, which is plus 2W. To find the area of a rectangle, okay, as a matter of fact, to find the area of any polygon is basically take a look at how we take how long the base is times how tall it is. Okay, so here we just call rectangle length and the width. So to find how long the bottom is, that would be length times how tall it is, which is width. So all the area formula is base times height. Okay, generally speaking, we just call them different names for their size in order to distinguish the difference. All right, as you can recall, square is where all 4 sides are congruent and the opposite sides are also parallel. So squares, we call them sides. Okay, each side we just call them S. So to find the perimeter, that will be S plus S plus S, which is 4S. To find the area, which will tell you how long the bottom is, S times how tall it is, which is another S. So S times S, side times side will be side square. All right, let me do parallelogram real quick. All right, parallelograms is a quadrilateral with 2 pairs of parallel sides. So the base and the top base are parallel and congruent. There's 2 slanted sides. The 2 slanted sides are parallel and congruent. The base of parallel is denoted. The base of the parallel is denoted as B, and the height is denoted as H, and the height and the base is always perpendicular. So to find the perimeter, I add all 4 sides. To find the area, I just take how long the bottom is, take how long the base is times the height. Alright. Now, if I will cut my parallelogram in 2 halves diagonally this way, what leave me with is 2 triangles. So to find the area of a triangle, that will be half of base times height. Okay, half times base times height. That will give me the area of a triangle, because triangles, the area formula actually come from being half of a parallelogram. That's the one that's always a half in front of a base times height for triangles. Alright, trapezoid. Trapezoid being a quadrilateral. It has exactly 1 pair of parallel sides, so that means the top base and the bottom base, okay, is always parallel, but they are not congruent anymore, because the key characteristic of a trapezoid is where one base is actually longer than the other base. Okay, however, their bases are parallel, and the height is always perpendicular to the 2 bases. Alright, to find the area, we just take a half times the height, and then times the 2 bases add up together. I normally call them big base and little base, sorry. Alrighty. Alright, let's take a look at some application here. So I got two types of problem here. Basically, I got perimeters and area. So let's be careful which one you want me to find. A triangular flower bed is created. The following figure represents the layout of the flower bed. How many square feet? So again, when you see the word square feet in geometry, that means find the area. Let's see. So find the area of a triangle. So 9 feet must be my base. 15 feet is actually my slender height. So my actual height always got to be perpendicular to my bases. So the 15 is actually not a this is a base, not a 6. All right. Make it worse. So the 15 is actually not the actual height. So I'm missing the height. So here what we can do is use Pythagorean Theorem. If you ever take Math 106, we talk about Pythagorean Theorem. We can use a Pythagorean Theorem to help us to find the actual height. So that means the side 15 is across 190-degree angle. So that makes 15 feet the hypotenuse, which we normally call the side C. So a squared plus b squared equal to c squared. All right, let's just say my base 9 is side A, so that'll be 9 squared plus, let's call this leg side B, which in this problem I'm actually saying height squared, equal to my side C, which is hypotenuse. In this problem is 15 squared. So this is going to be 81 plus h squared equal to 15 squared is 225. To get h squared by itself, I need to move my 81 over. So my height squared is equal to 225. It's still the same. Positive 81 come over, become negative, so that will be minus 81. So that's 144. To get my h by itself, we will need to take a square root on both sides, because as you can recall, square and square root will cancel each other out. So my height is equal to 12, because square root of 144 will be 12. All right, so now I got my height, I got my base. Now I can find my area. So my area of the triangle is half times base times height. So that will be 0.5 times 9 is the base. Height I just found to be 12. So that will be 0.5 times 9 times 12, which is 54. All right, so that will be 54 square feet. All right, so we're going to use Pythagorean Theorem to find my height in this case. All right, a triangular flower bed is created. The following figure represents the layout of the flower bed. How many feet of the landscaping edging? So you want me to find the edging. How many feet of edging do I need? So this one is actually trying to find the perimeter, okay, of my triangle. So in order to find how many feet of edging, I will need all 3 sides, since I'm looking for the perimeter. So this time I'm actually missing this side, which is the hypotenuse side, which normally hypotenuse we call the side C in the Pythagorean Theorem. So a squared plus b squared equal to c squared, and you can kind of tell these are the similar dimensions. 9, 9, 12. Earlier h is 12, so this side got to be 15. The hypotenuse missing is 15. If not, I can say 9 squared plus my side a squared plus the other leg 12 squared equal to c squared. So that will be 81 plus 12 squared is 144. That's 225 equal to c squared. So to get c by itself, we take a square root on both sides. So my answer, this missing side, is 15. So now how many feet of landscaping edging do I need? So I just add up all 3 sides. So 9 plus 12 plus plus 15. So 36 feet. I need 36 feet of landscaping edging. All right. Miguel wants to enlarge the perimeter. All right. So this problem is about perimeter of an 16 by 20 inch picture by 70%. Enlarged by 70%. So by looking at the dimension, what I got myself here is a perimeter of for a rectangle, 16 by 20. So let's just say this is 20. How about that? This is 16 inch. So I want to enlarge this perimeter by 70%. I want to make it 70% bigger. What would the perimeter of the enlarged picture be? So why don't we find the perimeter of my original rectangle here? So perimeter of a rectangle is 2L plus 2W. So that will be 2 times 20 plus 2 times 16. So let's see, 2 times 20 plus 2 times 16. That'll give me 72. All right, I got 72 inch originally. I need to increase by 70%. So that means I need 100% of my 72 plus another 70%. So that means I need to, so basically I'm going to increase, let me write it this way. All right, I'm still gonna have my 100% of my original perimeter, plus I need additional 70%. So what that means is I will actually end up, this will actually end up to be 170% of the original 72 inch. So I take my 72, simply times by 170%, which is 1.70. All right, 72 times 1.7, that will give me 122.4. All right, inches. Now, if you want to do it this way, if you want to just take the 72 inch times by 0.7, right? 70% increase by 70%. So I need to increase 50.4 and then add it back the 72. You will still come up with the same answer. Alrighty, let's try this. This is actually considered as a, you can count this as a trapezoid or a composite figure. Okay, either way, look at it, should give me the same answer. So this particular problem says a swimming pool is shaped excuse me, of the following figure. The homeowner wished to create a canvas over the pool. How many square feet? So I'm looking for square feet. That means I'm looking for the area. All right. So let's see. So apparently, by looking at the picture here, 15 feet is right here. This is 12 feet. All right. So that means up here, this 14 feet got to be the height. All right. So if I look at this as a rectangle plus a triangle, I can do that. So to find the area, so that means I will need to find the area of a rectangle plus the area of a triangle. So this is going to be a rectangle plus a triangle. Or I believe, let's see if I can do it this way. Look at this as a trapezoid. This 14 feet right here as the width of the rectangle, so that means, which is also going to be the height of my trapezoid. So if the height is 14, all right, up here, this top base of a trapezoid got to be 12 feet. So this whole entire bottom, the longer, all right, the longer base got to be 27 feet. So I can also look at this as area of a trapezoid. because if I use a trapezoid formula, that will be half times the height times a big base plus a little base. So that will give me 0.5 times the height 14 of the trapezoid times a big base, which is 27 feet plus 12 feet. All right, I can do it that way. Let me see what the answer is real quick. Let me do it right here. 0.5 times 14 times parenthesis 27 plus 12. So my entire area is 273. Alright, so if I want to look at it as a rectangle plus a triangle, that will be length times width for the area of a rectangle, plus the area of a triangle is half times base times height. So that will give me 14 times 12, or 12 times 14, plus half times the base of a triangle is 15 times the height of the triangle must be that 14 for the triangle. All right, let's see, 12 times 14 plus 0.5 times 15, the base of the triangle times the height of the triangle is 14. So 273. So either way, rectangle plus a triangle or a trapezoid will actually give me the same answer. So that will be how many square feet of canvas we need. All right, give you same picture. But this time the homeowner wished to build a fence around the perimeter. So that means this time I need all the sides. Right? And if I need all the sides, the down here is 22. This side on the outside is 14. So now if I look at this as a rectangle, then this is 17 up here. So the only missing side is this side. All right. So here for the triangle part, this is why I still want you to look at this as a triangle plus a rectangle. Because if you see this as a triangle here on the left, that means this side across from the 90-degree angle must be the hypotenuse. So if I can find the hypotenuse, then I can actually find all four sides on the outside. So let's say what my leg A is 15, my leg B is 14. So let's find this missing side before then we can add them up. So A squared plus B squared equal to C squared. So that will be 15 squared plus 14 squared equal to C squared. Let's find my size C here. 15 raised into the second power plus 14 raised into the second power. So that will give me 421 equal to C squared. So take a square root on both sides. Round your answer to the nearest hundredth. So let's see. Square root of 421 is 20 point, round to the nearest 100, that will be 20.52. All right, so size C is 20.52. So now the entire perimeter will be 20.52 plus the 15, the 17, which is 32. Plus the 14 going up, and plus the 17 come back across. All right, so let's see how many feet of fencing do we need. So 20.52 plus 15, 17, 14, and the 17 again. All right, my perimeter, 83.52 feet. Alright, so in this lecture video, we talk about area and perimeter of our rectangle, squares, triangle, parallelogram, and trapezoid. So we end up having to use Pythagorean Theorem to help us to find the missing side of a right triangle in order for us to continue to find the perimeter area. Alright, or to help me to continue to find the perimeter area of my trapezoid. All right, so very neat. besides using those area and perimeter formulas, we actually also end up needing the Pythagorean theorem to help us to find the missing side of a triangle. All right, that will conclude this lecture video on areas and perimeters of polygon. Thank you for watching.